So today we will try to build some agents that can actually run different functions, and in our case work with genetics databases. And we will also try to build multi-agent LLM patterns. But so first, let me remind some basic theory before we will go to the workshop. So overall, the transformer architecture is very simple. As some of you came from biological but non-IT background, I will just remind the basic idea. That you have some text, like for example here, and it gets the text as input, and then it generates next word, and the model, like on the right picture, it has like probability distribution which word to choose, and that's how typically things are generated. And in most of the cases, interactions with large language models is just sending them text and getting completions. Some software libraries try to overcomplicate it, but overall it's just sending text, receiving the answer. Now they try to a little bit organize it and split it into like messages that each part of a text that can be marked as either AI assistant answer or user or tool use. But overall, it's pretty simple. And the problem of this approach that we saw long ago is that actually each model was trained at some point, and obviously you retrain it from time to time, but you cannot like keep it retrained instantly. And when we work with cutting edge information, either news or science or other novel data, it doesn't have the knowledge. And this actually caught our attention some time ago, like a year ago. And there were also some jokes about large language models that they are like a stochastic parrot. So like they just select the next word, and they don't really understand what is happening and cannot work properly with cutting edge research. There was even a paper on this. We don't fully agree with this, but that was the problem. So here on the picture, some of you already saw it in my previous talks. We have like very inaccurate answer on very specific genetic questions, because most of large language models, they are just trained on general knowledge and often don't take into account some databases and also very novel sources. And we like at a year ago, at a bit more than a year ago, at Zuzalu Hackathon, we actually implemented the way for it to actually call the database. And the way actually how it is implemented is very simple, is that you can explain large language models that there are ways to get additional information by calling functions. Obviously, the only thing it can do is to generate text, but it can generate the text of like call this function with appropriate parameters. And you already with your application can execute it. And then you just send the model the results with initial text, what it asked, and results of execution of the function, and it takes into account. And here is actually a screenshot from custom GPT that we developed on Genetic Genie. And the main motivation for us was obviously to turn this kind of stochastic parrot into a research companion that will help solving great problems. For example, enhance and speed up aging research. And we already managed to let it call some function, but now we actually wanted to be more active companion in helping researchers. And with this, so here coming back, we had like 0 stage when it was just calling model. First stage, if we, or second stage if we count from 0, is when it can call some data functions and databases. And now we are actually coming to the stage number 2 that actually can interact with the user. And the way how it works is that we can make it in a similar way. Instead of just asking it to give an answer, we can simulate the way how you work in your organizations. Like, it's not like ask and give the right answer right away, but you have an iterative process when different people, like those who wrote, the reviewer, and different experts improve the result. And actually, this approach works. So this is a screenshot that from a popular use case on code assistants like Copilot. And what is important about this picture, so 0 shot is just when we ask the model. And when we use different ways to actually refine the answer with these additional questions, interactions, or several roles, you get really big improvements. So here you can see that in some cases you can get 40% improvement, and some cases you can have a weaker model like ChatGPT 3.5, but it's actually, when improved, it does better than 0 shot GPT-4. And today we actually will reproduce some of the typical agent patterns. So first is a tool execution, where it just knows you instructed about the tools that it can use, and it just generates text to call this tool. So because many of you are of biological and other non-programming backgrounds, so today we will use a more visual system rather than making it a programming workshop. But that's the general idea. And also I give a link to Andrew and G series of posts that can be of interest for some of you, called agentic design patterns. And technically today we will reproduce part of genetics Genie about looking into different genetic variations. And a second thing that we will work on is actually iterative work. So here is an example that is close to many of you with programming, that you write code, you debug it, sometimes you even ask the user to answer, and after several iterations you get better. In our case, we will actually use another case, the case of advising which drug to use for better longevity. And some of the developments that we are doing, so apparently many things that we develop, so we don't use that actively flow-wise, the ones that we will have in the workshop. We more prefer programming, and we also created a simple code library called Just Agents, after being really overwhelmed by unnecessary complexity of existing programming libraries that deal with agents. And with this, I give the word to Olga Borisova, who will explain some theory about biology and genetics for those of you who don't have such background.
Yes, thank you very much. I'll also share my screen. And yes, so okay, everyone, welcome to today's workshop. I know not everyone here has a background in biology, so I want to make sure we all start on the same page. I'll just explain a few small things. that will come up today during our discussion. The first one is RSID, and Maria will probably mention this a few times today. So what is RSID? It's actually like a special code, I would say, that is given to a tiny spot in our DNA sequence, which is called SNP, or single nucleotide polymorphism. Think of this like of a label, actually, that helps us identify and talk about specific spots in our genome, which are different between different people. It's kind of having a unique ID, or I don't know, QR number for a book in a library. Yes, it makes finding and referencing things a lot simpler. So RSID is combined from reference SNP, which is RS, and unique number. And it's the same in articles, in databases you can use, or if you have already had your genome sequenced, you also have results like a list of RSIDs. You have substitutions in, and it looks like this RSID and your genotype you have in that specific spot. If you read kind of old articles, you might have seen SNPs named differently. So before it was referenced like a name of a gene, for example, MTHFR or other gene, and then specific change or amino acid change or nucleotide change, it could look this one or this one or that one. And then it was just kind of difficult to understand if you read one article, then reading another article, what all is it about? Is it the same thing or not that simple? And when genome sequencing technologies were developed and so many of SNPs were actually known, it was a need to give that specific numbers. What is actually RSID? All of them you can find in the DBSNP database, and you can find the gene where this actually SNP is located, and or like a location if it's a not coding like sequence. And what is SNP? Yes, like RSID refers to a specific SNP in our genome. They are not twins, but actually genetically they are very, very identical one to each other. And things we are different are single nucleotide polymorphisms mostly. And actually, SNPs is one of the most common ways people's DNA can differ one from each other. And each SNP is like a one-letter difference in our DNA sequence. So what you see in your genome test, if you have made one, it's RSID, which refers to a specific point, and then like a substitution you have there. The second thing that will be talked today is a little bit about rapamycin and mTOR pathway. Rapamycin, or like RAPA in short, it's a very interesting drug. It's actually a drug which was approved by FDA, and it was approved for a patient who's like goes through graft. Yes, so it's used to help transplant patients by preventing their bodies from like rejecting new organs, like kidney, for example. And rapamycin has a really fascinating story of development. It was opened in 1970s from a soil sample on an Easter Island, which called also Rapa Nui, and it was a specific bacterium in that soil called Streptomyces chytroscopicus, and this bacterium produced rapamycin. And actually, it was developed as a kind of antifungal properties, like antibiotic kind of. And later on, scientists have found that it could suppress immune system, and by that case, help to improve graft survival. And also, it can help to fight cancer. And a lot later, in 90s years, it was discovered that rapamycin works also by targeting a protein called mTOR. And then it was discovered that it is can have anti-aging properties. And now I would say it is the most famous drug in anti-aging medicine. So what is mTOR, which ropamycin is targeting at? It's mechanistic target of ropamycin, and it's a protein in our body that, like a master controller in our cells, it analyze a lot of signals like nutrient availability, energy availability, growth factors, energy, and actually it can be in two modes. And when it is active, it tells our bodies like to go full throttle. So it's great when you are young and growing, but as we get older, this constant go can lead to specific problems like aging, yes, and aging related diseases. And ropamycin like inhibits this mTOR and says, hey, slow down, let's fix some stuff. When mTOR is inhibited, it helps to activate protective pathways and mechanisms like autophagy. And two things that can inhibit mTOR, the most known is ropamycin, and the second one is calorie restriction or fasting, like when nutritional components are scarce. And the most fascinating stuff about ropamycin is that inhibiting of mTOR and usage of ropamycin actually prolonged lifespan across all tested model organisms, from yeast to mouse. Yes, and in mouse studies, the results are the most amazing. For some studies, it was up to 50% increased lifespan, which were not reproduced like in numerous studies. But actually, like about 15% is very stable results, and ropamycin is like a gold standard for life extension in my studies. What about human studies? It's also interesting. There are some clinical trials now already in phase 2. And here in these clinical trials, ropamycin is tested specifically for aging. So not like it was FDA approved for graft survival, but for aging, like how uptake of ropamycin affect visceral fat, bone density, lean body mass, liver function. So all work of all systems that got damaged by aging. It's also, there are some clinical trials for some changes in skin and for immune aging. But a lot of things are still unknown about ropamycin in relation to aging, not exactly mechanisms. There are some adverse effects like immunosuppression, hyperlipidemia, hyperglycemia, and actually in my studies, it was shown that the best results were obtained for a combination for acarbose, for example, and ropamycin. So acarbose can like slowing down its negative effects. What about safe dosages and regimen, which we can use like for not to age, for example, to age slower? Which results of clinical trials are already available, which are promising, which are not so? Whether there are safer alternatives, which are possible combinations we can use ropamycin with. And that's a lot of information that we can actually obtain by using LLM agents as well. And so I think that Maria can tell a little bit more about that.
Yes, thank you. I'm going to show you my screen. Just a second. Okay. So I will be telling about Flowwise. It is this platform that we are going to use today to create the customizable LLMs. And as Anton mentioned, it will be mostly based on like visual stuff, so no previous code knowledge is needed. Maybe a little bit, but we won't get into details much into it, so we can avoid it pretty much. And let's start with saying what is Flowwise. So it's an open source platform that you can install locally on your server and use it. And basically under the hood of it is LangChain and Llama Index. For those who doesn't know, LangChain is a very known library to make customizable LLMs. And it's basically using absolutely all the same things that exist in a LangChain, just to make it visually more easy to navigate through it, because those who have used LangChain should know that it's pretty hard and complicated code where you can get confused very easily. And with this, people, even without any knowledge of programming, can use it. And as well, it's based on Llama index, but for today, we will use only LangChain. And Anton already mentioned a little bit about agents and chains, and I will add just a tiny bit more information about it, because the core of any flow within Flowise is exactly agents or chain, and later we can combine them in multi-agent system. So like the overall thing that you should understand about agents and chains is that chains are more rigid. It's basically a sequence of agents that will be always like followed, and it's kind of hard coded. And in some of those sections, you have to call LLMs and ask them to do something specific. And agents are more complex because they are more autonomous, and it's basically like an LLM to which you provide a bunch of tools. And LLM decides, depending on what input the user provided to you, which tools it should use in this specific case. Then make some observation using this tool. Then it can analyze this observation and call more tools if necessary. And these actions keep repeating until LLM is satisfied with the answer, and this way it produces output. So this autonomy makes it less predictable, but at the same time it can handle more complicated tasks and better user interactions. But at the same time, because it's so autonomous, it is harder to debug and less predictable overall. Chains, on the other hand, is easier to scale because they are predictable, rigid, and it's also easier to debug because you know exactly what will be the sequence of actions. And before going to examples, I will show you the interface of Flowise. Here is our deployment on our server. I will share the link with you, and if you want, you can also open it and check it out. So for the interface, on the left, we have here chat flows, where will be your chat flows with agents and chains within them. And we will create today one agent here. Then here is agent flows, where you can build a multi-agent systems where multiple agents will communicate with each other. We also will create one of those systems. Here is also marketplaces. We've already created agents and chat flows, and maybe you can find something that will be useful in your specific cases, and it will be already created one, so you can use it without creating anything from the scratch. Here is tools. Within chat flows in Flowise, you already have created existing tools like web search, for example, but you can also create your own custom tools, and they will be here. There is also OpenAI assistants. For those who knows about existence of OpenAI assistants of OpenAI, it's basically absolutely the same. You can create or even recreate your already existing assistants here. Also here we have credentials. Here you add all the credentials that you need for your specific agent. Here we have on the OpenAI API to be able to call OpenAI models. And Langsmith API I will later show you, but overall this is a tool that you use in LangChain to debug stuff. So you can use it in Flowise as well. You connect it, and the debugging process will be absolutely the same as if you were just coding with LangChain. Here you can also store variables, but in today's example, we won't use it. API key of Flowise itself. Later, I will also show that you can pretty easily integrate it in your application or web page. And also here we have document stores, so you can upload documents, and your agents or chains can extract information from the documents directly. Before starting, Flowise is created in a way that we don't have accounts here. And I would like to know how many people is going to actually follow something that I'm going to show, or you would prefer just to watch. Please, someone who is going to follow me, write something in the comments, or maybe tell me using voice, just to know. Okay. In this case, so we won't like over touch each other's works. I would probably ask you to create, like, for example, James will have number 1, and when we create add new, you will give a name 1, Daniel will give name 2, and surname, sorry if I pronounce it wrong, number 3, and so on. The more people write, the more number will be, okay? So we want overflow. Yes, and I'm going back to presentation just to show the example we are going to do. The question that we are going to improve will be a question about RSID that Olga told us about. So here I'm asking on about a very specific RSID, and I can tell you already that this whole answer is a hallucination because it's identified wrong gene. This specific RSID not located in this gene, and it's located in FOXO3 gene. So vanilla ChatGPT gives you an output with completely false information. Meanwhile, using agent system and providing it with specific tools that can take information from databases, we improve the answer to the right one with lots of extra information. And because we provide our databases that contains also information with focus on longevity, you also can see that it provides very specific information about different alleles in this RSID that can either improve your chances of longevity or decrease them. And now we are going to, I'll check no one else messaged. Okay. And now we are going to start creating an agent that will be able to create such an answer. So for these people who is going to follow me, you click on this icon to save it, and you will name it like 1, 2, 3, or the number I told you. And I will name it genetics Genie answer, let's say. About the interface. So as I said, it's very visual, and it will be based on agents or chains. So it will be like the core node that you should place in the first place before starting doing anything. So in our case, we will create an agent because for our task, it will be the most suitable case. It's, as I said, more versatile and can answer more complex questions because it can choose from different tools. So for this, we open agents, and we are going to use tool agent. It's the newest one, and it works with different models. And it's the best one for our specific case. And it's called tool because you can put as much tools to it as possible. So we put this node. And each node in general will have like a set of things. It should to a set of things which should be connected to it. So these asterisk means that it's obligatory to connect this thing, and some other things that doesn't have it means it's optional if you have it, if you want to have it or not. So for tool agent, we have to connect tools that the tool agent will decide which to use, one of them. Then we have to connect a memory. Memory is needed to make these observations as I showed you on the picture. So it will make an observation, store it in memory, remember it, remember the input from the user, remember the maybe other observation from overall tools, and then create an output using all this information. And of course, we have to add some kind of a model that will orchestrate all these processes. As well, we can add input moderation if you need it. And there is 2 options of input moderations. If we use in OpenAI models, we can use the same moderation as they use on their website, so it will be absolutely the same. And there is also simple prompt moderation. It's like a filter of words by words mostly. So you can filter out some specific words if you don't like them. Okay, and now we are going to start adding stuff. So let's start with memory. We will use buffer memory. For this, you put this buffer memory node here and just click here and connect. We connected, that's it. Now we are going to add chat OpenAI model. This one. Here we add credentials that already exist on our website. You can use, those who follow me use these same credentials. And we are going to choose GPT-4o model. And the temperature we will put lower. The temperature is a variable that defines how creative the answer of model should be. The higher, like it's from 0 to 1, the higher the number, the more creative it will be, and the lower it is, the less creative it will be. And then we connect it. And now we are going to add some tool here. In our case, we can create this agent with this output in different ways. First, I will show you the one that is doesn't require as much code. For this, we will have to use chain tool. Chain tool. Chain tool is you can basically connect to this tool a whole chain. Chain is a thing that can be alternative to agent, as I said. So you can create a whole chain of these sequential actions and connect it to this chain tool, and then you can connect this chain as a tool to agent. We are going to use it because we need a very specific chain, open API chain. Open API chain, we connect it like this. Yes, I didn't say why exactly we need open API chain. It's because the way our custom GPT that Anton mentioned works, and we will kind of replicate functionality of it in Flowwise, is that we basically make API calls to our API. Here it is. That's how it looks. So for those who doesn't have much of programming experience, it's something like a server. On our server, we have some databases stored, and all this stuff that you can see is like a methods which you call to get out of the server this information. So for example, we want some specific information about the RSID that I mentioned in our example. In this case, we will make a call, and instead of these curly braces, we will put this exactly RSID. So let me show you. It can be shown here, like that. We provide this information to our server, and then we get the output with all the information from all our databases available. And all this answer will be returned to LLM. It will analyze it and create an output with right already information, because it was taken from proper databases, not a hallucination. So for us to be able to make calls, we need to use this OpenAPI chain. OpenAPI is a specification. We have to provide here a YAML link or YAML file. And this is like a file that will describe how all of these methods work, what they do, and what information should be retrieved for very specific questions. We have very different methods, as you can see, not only RSID that we will use specifically for this our case, but we can use information about genes, about pathways, diseases, and so on. So right now on our website, we don't have YAML file, we have only JSON file, but I already created a YAML file that I created out of JSON file, and later we will probably add YAML file on our website as well. And this file we upload. And basically the same thing you can use with any APIs that you want to use. Just find the YAML files, upload them, and basically the LLM will know what methods to call to answer the questions. And also, as you can see, here is a node, asterisk, we have to provide to it chat OpenAI model again. We connect it, as again providing open API credentials and changing the model. And always remember that you have to save it. Otherwise, all the changes that you do here won't be applied. And when you try to have a conversation with it, it won't know that there was some changes. And we forgot to add chain name. Better to provide name in lowercase with underscore, and provide a chain description so the LLM here knows what this chain does. So it is helpful to answer questions about genetics, for example. And here you save it. And now we can try ask question about this RSID from the example. Tell me about okay, already good gene, FOXO3, all right. And yes, longevity weights also was taken out of it. And here on the top, you can see what exactly was called, what input was provided, and what was the tool output overall, which is also useful for debugging. Okay. Mm-hmm. That's basically it. And as I said, apart from RSID question, we can ask questions about genes and other stuff that were in these methods. And the other option that I wanted you to show, I will show you already created one, and I won't like put lots of emphasis on it because it is it requires some programming knowledge. But I will show you how you can do it other way if for some reason you can't provide YAML files. So this is all this node is like custom tool. Those that I mentioned that in the previous interface you could check. Here the name also always should be in lowercase underscore. Also you provide tool description. So LLM should know what exactly it does. And there is a limitation, so you can't provide more than 1024 signs in it. And basically the same functionality as was done here, I replicate within this code, and we just make API calls to our server, but more manually, let's say. Here is some variable that LLM knows it should provide, like it will generate a link, method name it will choose, the right one that it should be, because we have methods that are get and post, and also here is a body for post method to provide some extra information that our server requires. And for this thing to work, you will have to provide, this one I didn't show you yet, additional parameters. Basically, it's like a system message for LLM to know how to behave. And here you can alter the normal behavior of LLM. For example, you can make it ask some question before starting a conversation with the user, or add some other functionality. And here I am writing a very basically that the same information that we have in this YAML file that we provided in the previous flow, but I do it pretty much manually and describe all the databases and everything so it can make proper API calls. It's for those who are interested in alternatives if it's necessary in your specific case. And a little bit of other functionality. Here you can see different codes that help you to integrate Flowwise into your application. This specific code will help you integrate Flowwise in your web page. And the way it will look, it will be something like similar to this, like a circle in the corner of your website, which you can click, and there will be opened a window where you can have a conversation with the bot. And here you have different languages of with code that you can integrate into your application, depending on what language you're using. And here is other interesting stuff. Here you can load chat flow and export chat flow. So for example, this chat flow you can export. All sensitive information like credentials and probably custom tool as well won't be exported, but the overall like template will be exported, and you can easily migrate it from one server to another. For example, it will be easier than to create all this schema from the scratch again. And another interesting thing is configuration. Here specifically, I want to show you this analyze chat flow part where you can connect it to LangSmith. So for this, you provide credentials and provide a name with which this flow will be shown in LangSmith. And then you make it turn on and save. And after that, all the conversations will be shown in LangSmith. That's how it looks, this website. You will have here projects. And here we have all the projects that I have. And for example, this one is stored as genetics Genie. And we can check our last conversation with it here. And here you can see all the processes and details, how exactly everything was executed, in what order. And it's very useful to understand, to debug, to understand where something got wrong, to see exactly the errors if they appear here. And the thing that I showed to you on our API, you can also see here. So this was the actual original output from the server that later already LLM transformed into proper answer. That's it for this example. And second example is rapamycin case. Here we ask LLM about should we take 5 milligrams of rapamycin once a week, providing some information about ourselves, that it is a 50-year-old male, moderately overweight, slow vaccination response, high IGF-1 values. And the vanilla ChatGPT answer is pretty generic. It provides right information, but there is no sources, and the overall answer is very vague. And we can improve it to that level currently. And let's see how we can do it. At first, we can even test this one chain that we created, asking the same question and see what will be the output in the current state. And it will take a while, as far as I remember, because it will make a few calls to our server and also make a hybrid search, which can take some time. And the spoiler would be is that the overall answer is nice. It will provide some links, but there can be some bigger improvements. And that's why we are going to finally use multi-agent flow. While it's generating, I will show you. So we are going to agent flows. And here I will show you already created by me one. And here it is. So the way multi-agent flows usually work, there is a supervisor, like a manager who will orchestrate all the decisions and all the actions in between all the agents. Oops. There are workers to which you assign a very specific tasks to do. Like this one would be a biologist. It will specifically answer questions about genetics, papers, and clinical trials. Another worker will be a critic who will take a quality control over biologist, make a review of its answer, provide some critique to it, and say overall what can be improved in biology's answer further. And this way we recreate this reflection pattern that Anton mentioned. And it's pretty useful because in our specific case, it won't significantly improve the answer, but it will add a pretty nice details to the answer that are valuable, so the overall answer is improved. But I think with maybe GPT 3.5, the overall answer would be significantly improved in this case. So for other details here, we also provide to supervisor chat OpenAI model. And it is supposed that this chat OpenAI model will be used by everyone in this multi-agent system. But if for some reason you want a very specific worker to use a very specific model, you can provide to each worker their own model. So it's very useful to do. If there is a need for it. And also for each worker, because worker is basically an agent, you can provide a tool to use. And the interesting thing here is that you can provide the whole chat flow. For example, you can provide some of the chat flows that we just created. And the only thing that you should add only would be the name for it, again, better in underscore in lowercase. And again, we provide the description so the LLM knows when to use this tool. And also here we have iterations. It will limit the amount of time each of the workers do their work, because sometimes it can take lots of calls and it can be costly. So to avoid it, we can limit the the amount of iterations. And due to some technical limitations on our server, I will show you how this multi-agent system works on local host. It's absolutely the same. It's supervisor, also worker, the same biologist, the same critic, the same Open API model, and the temperatures I put lower, so it won't be very different answers each time. And I also provided the same chat flow that we created earlier. And let's try to ask it the same question. It will take a while because the way it works, you will see right now. So here is supervisor. He understands like what was the user's input and what the user wants as an answer, and it creates a task for biologists first. So it says to him that it should analyze the characteristics and pay attention to longitudinal data in your analysis because that's what the user asked. Then biologist does the analysis and it will take a while. Meanwhile, I can show you the previous answer that was done already, and we further can go back to what is going on right now. So yes, it was the same question. Biologists use these tools and was asking about very separate parts of the user's input, like specifically about IGF-1 values, specifically about slow vaccination response, and on all that. Oh, this part was generated also in our question. Here we provided lots of links. Lots of clinical trials were found that were related to rapamycin and to specific levels of it. And as you can see, overall answer is much more detailed with lots of links and more reliable overall. And then supervisor asked critic to analyze the answer of a biologist and create some reviews on it and provide some improvements maybe. And overall, from my experience right now, the overall outputs vary a little bit. So we create everything, but overall, it usually provides some minor improvements that overall makes the answer even more detailed, even more versatile. And from the previous example, if it won't make me go back again, I will be able to show you that here in this specific example, for example, critic suggested to add some information about that user should make a genetic examination on a very specific genes to understand what should be the better dosage. Sorry, it was again put me back, so I wasn't able to show you. But overall, in our specific case, it provides just some extra details, which is also valuable, I think. And that's basically how multi-agent systems work. And you can create something very similar to it. And that's it from my part. Anton, yes, you can.
Yeah, so thank you very much for this workshop. Could you please send the original YAML file because people cannot reproduce?
I don't know if I can attach it here. Can I? I don't think I can in... Okay, I will make
it. Upload it somewhere and give a link.
Yeah. Gonna do it. And meanwhile, maybe some of you have questions.
Yeah, I also want to highlight that actually, so right now we are experimenting with multi-agent systems to improve answers on biological and especially in longevity questions. And also, all of our effort is open source, and we are also looking for people who are curious in contributing, because actually there are way more things to be done than people in our team. And also, I want to say our gratitude to our supporters, especially Hills, that made some donations. Also to Gitcoin, VitaDAO, and everybody who donated in our crowdfunding campaigns. Maybe we can just allow people to talk. Razvan, maybe can you talk or only write? You can raise your hand, and maybe it will be more interesting just
Hello. I can talk. Hey, hello. Thank you, Anton. Thank you, Olga. Thank you, Marfantika. So my question is, how do you measure that an answer has been improved?
For now, from my side, the answer that I showed to you, I measured it pretty basically manually. I was reading the answer and comparing it. It wasn't something automated for now. Yes, that's what I showed to you. I wasn't able to show actually, but there were only minor improvements in this specific case. As I said, only some extra details were added, and sometimes extra tool calling was happening, and that's pretty much it for this case.
Well, overall, there are several ways. So the easiest to implement but harder to scale is manual. So you just see if you like it or not. Then also you can actually use LLMs themselves to evaluate the answer, especially if you use multiple LLMs. So even if one is biased, others, they can have less unbiased opinion, or more unbiased opinion, yeah. And also you can have like an agent that will try to verify the sources, like to see if the links are actually clickable, that the content is indeed in the place where it was. But obviously there are like no silver bullet, that even if you have like some LLM workflows to correct and self-check the answer, still you need some manual checkups, unfortunately.
Okay, I understand. So you're saying no silver bullet. I was wondering if you have kind of like a golden test set that you can always check your LLMs to see if they have not drifted right after you train them and retrain them, or maybe your consortia of LLMs actually have a good accuracy overall as a group.
Well, the thing is that for biomedical questions, there is a data set called PubMed QA, and I believe several other data sets. So for PubMed QA, I can give a link. The problem is that there is like a limited set of the data set of the benchmarks that people can use. In case of our main interest, biology of aging, we don't really have a benchmark that we can use to see how it performs, because so far it requires a lot of effort that we like just several people in this team. It would be great to make one, actually, at least to have some general benchmark. But still, even if you have a benchmark, the real users' questions, they will probably, with big chance, will not raise part of the benchmarks on which you have ground truth.
Definitely. how about, I mean, continuing on the same kind of questions, what if you have kind of like a critical agent that tries to go step by step for the reasoning of the agent that created the answer? Like, okay, so RS1 is related to RS2, for example. And then the critical agent goes like, okay, but what do you based your answer on? Please provide me the links to the research, right? So do you know of a framework that tries to decompose step by step the answer?
Well, the thing is that you technically have to configure it. I know there were like papers and endeavors where people like wrote really sophisticated pipelines, but they were like in some specific domain area or for some specific examples. So technically you have to build it, unfortunately. And also there is another problem that actually for most of the agentic workflows, because it's pretty new. In many cases, LLMs, they make mistakes with delegation, like to which agent to delegate. And often, like when as soon as you increase complexity, like number of agents, number of steps, you get to many cases when it just goes to infinite loop or does something crazy. Things are getting better because right now, like everybody is starting to understand that agents are very interesting, and people even like in new generations of models, they actually make sure that they have use cases to check that those models can have like reasonable agentic workflows. But right now, so far, you have many problems. I think, Maria, I think you had like a lot of problems to make it work as well, right?
Yes, it's very sensitive to prompts. You have to be very precise because sometimes it gets lost in between like agents and to which assign which task. So yes, you have to be very precise and accurate in lots of stuff.
Okay,
Yeah,
got
so
it.
I
Thank
can
you
say
very
that
much. So yeah, I do understand that these LLMs have a tendency to hallucinate. I was just wondering if there is kind of like a process or a methodology to make sure that they do not hallucinate answers when you're actually looking for a real answer. Do you hear me? That was all. That is it. That's it.
well, I mean, there are problems. I mean, I cannot like address everything. So I can say everything is pretty experimental. There are even like libraries that have like thousands of stars, and they cannot do even basic things like QAI, for example. So that's like the stage that we have to face. I see there are some other questions. So James had issues like reproducing. Actually, I don't know. Maybe you can contact Maria after the workshop, because I think debugging can take some time. And actually, I would love to hear any feedback or any other questions.
Actually, just like a continuation of what we discussed, and I think it's pretty easy to understand if it hallucinates and hallucinating while you provided some data to analyze. Because if you like do some like provide some data from some database with links and everything else, you can just check if these links are like correct, and that's it. Because if I remember from this previous first article published with LLMs from Java, there are like there are some problems with like this hallucinated links and everything like this. But if you will provide links to it, and you can just check if like links were not changed. To me, just
well, I can say a few words. So the actual APIs that we are using, we have an index of aging research papers. So we have like on the API that we dealt. So we have some methods that get like information from databases, And we also have a hybrid search that uses a mix of regular search with semantic search. And I believe the one that we used was, I don't know, about like several 100,000 papers. Yeah, so it was actually part of the search was used there. Okay, guys. Also, if you have like any questions, does everybody have our contacts, me or Maria? Yes. So we have LinkedIn page. We also have a Telegram chat that for those of you who use Telegram. And we also have, so in our case, the team that develops Longevity Genie is the same team that also develops just-dna-seq, personalized genomics platform. So you can either contact us. So on our website, we actually give, so on our website, we give the Telegram group that you can use, but you can also find us on social media. And also for just-dna-seq, in our case, we use Discord. You can also like load us with AI questions, because the team is pretty shared between projects. And we also have a GitHub organization. It's probably we need to clean up a bit because we have too many repositories. Some of them are a bit out of date. But we actually really welcome if you would contact and give feedback and think how you can contribute.